Hi guys, we're presenting again for DGAL, or Distributed Genetic Algorithm Library. I'm Colin.
I'm Paul.
So, just to quickly recap what the project is. Essentially we're just making genetic algorithms distributed. And a genetic algorithm has individuals which calculate a fitness, and they're included in this big population. And you create new generations of these populations once every individual has been evaluated, and keep the best and try and generate new ones to continuously improve your solution. So we have a couple, in the distributed sense, we're communicating to all these other nodes in the network saying, here's our best individuals, maybe if ours are better than yours, throw out yours so that you can continue working on a better solution instead of wasting your time with something that's less optimal. So, here's things.
So I joined relatively recently, but what I'm working on is termination conditions. So the generational process is continued, new generations occur, we create new units and their fitnesses are evaluated until a certain condition is raised, where that can be either a certain number of generations has been reached, computation time or money, a manual inspection, or various things that can determine when you want to stop and when you have your best fitness level reached.
So last time I mentioned that I wanted to use 0MQ for networking. Unfortunately, because of some limitations with 0MQ, I can't use it, and I'm going to have to wind up writing a lot of it on my own. One of the biggest issue was not being able to identify where messages are coming from in 0MQ. There's no facility for saying, hey, this is coming from node A instead of node B, and we really need that because we need to tell specific nodes when a message comes in, like saying, hey, I joined the network, but we don't know who joined the network, so we can't tell the other nodes with 0MQ. So that's why we had to ditch 0MQ. And a lot of the other messaging libraries are not exactly mature enough to be used in this situation. We looked at NanoMessage, which also is unstable at best. It's still in an alpha. Maybe later it'll work out, but for right now, it looks like we're gonna have to write a lot of it on our own. So some things that we could use help with. So peer-to-peer networking, I don't have much experience with, and right now, as long as this cluster is all on a local network, it works out fine. But my goal at the end is to be able to kind of set up, I hate the word cloud, but kind of like that, so that we can, you don't have to be on the same local network. You can just throw up a coordination server and start off a bunch of different boxes and have them all communicate. But if we want to do a ring communication, we need to be able to connect directly to each of the peers or each of the nodes. And because of firewalls and whatnot, this becomes a problem. And since I don't have much experience in this issue, I'd be looking for some help on this. Right now, my options are UPnP and TCP hole punching, which I don't fully understand, but apparently that's what Skype does to do their peer-to-peer networking. So if anybody has any information more on that, please let me know. And as for new things planned, I'm looking to, as long as you're on the local network, I'm looking to get rid of a coordination server, or so to say, by doing peer discovery on that local network. So you just send out a broadcast message saying, hey, I'm on this network now. Please, add me to your list of peers, and this way we can avoid any sort of bottleneck that a coordination server would be creating. So hopefully that'll improve a little bit of the performance. And that is pretty much it. Thanks to the usual people. And does anybody have any questions?
So for zero MQ, is sending a message with an identifier at the start not an option?
So getting an it is, but getting a proper identification that can be used between all the nodes is slightly difficult. And it would be a lot easier if the coordination server could just say, hey, this is where I'm receiving it from. This is like the public way to access it. Because if you're connecting to the coordination server, it already knows how to contact you. Whereas with ZeroMQ, we would have to figure out, what network interface are we on? What's our public-facing IP address? What ports are open and whatnot? So with ZeroMQ, it doesn't allow you to get any of this information, at least not without really hacking apart ZeroMQ and putting a bunch of your own code. So for that reason, it winds up being easier to write our own networking layer. Anything else?
Yeah, I was wondering how distributed out the sign that problem. How do you actually get that kind of fitness function and initial population? How does one get that into the system to begin with?
Okay, so right now there's just an individual base class that whoever's using this library would extend, and they provide their own fitness function just because we have no idea what they're going to be doing with it. So it's really simple. You just extend an individual class, write your own fitness function, and then you can override some of the like population control stuff. But for the most part, you really just have to write a fitness function, and it handles the rest of it. Yeah, and that's pretty much how that works. Yep.
I mean, you could use ZeroMQ and just like write a broker yourself for ZeroMQ, but if you don't feel like doing that, have you looked into RabbitMQ?
I have, and Colin actually said don't use it because it's a pain.
I mean, you could implement the broker yourself on ZeroMQ though.
I definitely probably could do that, yeah. But at that point, if you're writing the broker on your own, you kind of like that's kind of like the whole point of ZeroMQ is like they provide a lot of this stuff for you. Like, yeah, the message encapsulation is nice, but when it comes down to it, I could do that on my own too. But I'll definitely look into that. Anything else? All right, thank you.